Assalamualaikum and hello. Today we will be presenting our geotechnical engineering project titled Slope Stabilization using rubber materials which are tires. Before we begin, we would like to introduce ourselves. We are from Section 2 Group 3 which consists of 4 members: Muhammad Arif Ahmad Muhammad Razi, AA200254, Nur Akila binti Hisham, AA200404, Nur Atira Batrisha binti Ramli, AA200228, and Jaya Arasan anak lelaki Anbarasan, AA200126. Soil erosions are one of the deadliest natural disasters that can cause economic loss. When the crucial stress peaks in a brittle soil stress strain curve, shear strength diminishes. This causes slow collapse and slope failure. Geotechnical engineers worry about landslides and other gravity-stimulated mass movements. Geologists worry about landslides worldwide, especially in geologically dynamic locations. Nature and man-made construction have sloped soils and rocks. Sloping the land creates highways, dams, canals, and stockpiles. Rain and water affect its and other world's topography, causing unstable slope. A stable slope requires skill and science investigation. In recent years, waste tires have been used in geotechnical engineering, especially soil stabilization. Ancient civilizations used soil reinforcing techniques. Ancient ages also used simple things to strengthen soil. Today's geotechnical engineering also still uses soil stabilization. From natural textiles and steel to geosynthetics, reinforced materials have evolved. Many soil reinforcing materials are light, easy to build, cheap, and easy to produce and carry. Soil strengthening improves soil strength, stability, and mechanical properties. This study aims to investigate rubber tires' suitability for slope stabilization. This compares rubber tires to other materials for slope stability. It also examines how rubber tires overcome slope failures and on hills and land.
Now I will continue with the literature review. One of the materials that can be used to reinforce the soil is cup tire rubber. According to a 2015 research by Ramiji, the size of the rubber tire also affects the condition of the soil. This element will increase the shear resistance of the medium. It will increase its stability and bearing capacity. Next, numerous case studies documenting the effective use of rubber tire in slope stabilization application were the subject of research by Haji Azizi and friends in 2019. Tire reinforcement can increase slope strength as higher stress levels have been driven into the soil mass. Rubber tires have high tensile strength, good anti-friction, fine flexibility and durability. This method is not only able to stabilize the slope but it also environmentally friendly and also save costs. Lastly, according to a 2020 research by Minal Hizadeh and friends, waste rubber tire can improve bearing capacity, add slope stability, and other useful applications in civil engineering. Rubber particles can further increase the strength of the sand. The combination of rubber and sand can further increase the bearing capacity and shear strength flexibility.
Now we move to methodology. Soil erosion is one of the worst natural disasters because it puts people live in danger and hurts the economy. When the critical stress reaches its peak on a stress strain curve of brittle soil, the shear strength of brittle soil decreases with more continuous strain. Therefore, waste tire were recently introduced as a material for slope stabilization. There are two principles of this study. The first one is to find soil type with the same water content and density. Second, conduct equivalent tests on soil fiber rubber mix. The purpose of a retaining structure is to reinforce and stabilize some material. According to the load support mechanism, a retaining structure can be divided into two broad categories. The first one is internally stabilized and second one is externally stabilized. Earth retaining structure. First, tire-based earth retaining structure rely not on the tensile strength of the tires but rather on their connection. The most prevalent material used in this application was polypropylene rope with a diameter of 6 to 12 mm. Plastic fastener with a high tensile strength could result in a 25% more robust attachment. Next, researchers examined application of a retaining structure based on vehicle and no uniform model of tire could be developed. In addition, for infill and backfill material, practically every type tire shape was tested in sandy and poor local soil. Most investigations have indicated that fill material has little effect on the mechanical behavior of system. However, tires with one sidewall removed were recommended for cohesive soil. Last but not least, most of the previous studies were limited or reduced and full-scale model. Most of them measure the tensile resistance of tire inclusion and their connection pull-out resistance and soil and tire frictional properties.
Result and discussion. Overall, the research found that tire-based RSS applications outperformed commercial alternatives like as geocells and geotextiles in terms of reducing the depletion of basic raw materials supplies. However, in order to define a full design framework and parameters with suitable external and internal inspections targeted at constructing safe structures that optimize materials utilization, more research is required. Overall, research reveals that extending the length of insertion and lowering the distance between layers decreases vertical earth pressures, horizontal deformation, and tension inside the reinforcement, while also enhancing bearing capacity. It also increases the performance of the soil mass, acting as if it were a completely new component, and it causes non-brittle failures. More research is needed to test these tying techniques and to improve anchoring length, spacing, placement, and depth.
The usage of rubber tires not only solve landslide and soil erosion problems, but it also raise villages' understanding of soil and water conservation, which increase agricultural production, lower poverty rates, and improve quality of life. The slope is stable if soil shear acts as a force retainer against gravity, creating strong geostatic stress at certain angles. Vertical tension and horizontal stress make up geostatic stress. Imposed load refers to the weight of construction on sloped ground or nearby. If stress exceeds shear force, a landslide will occur. Expansion upstream will increase water flow downstream, adding to the land's demise. The study method led to the notion of developing retaining structures based on the slope surface configurations. These earlier stages are necessary to determine the slope's instability and collapse. In addition to lateral or horizontal soil stress, Malaysia's hot, humid climate contributes to soil failure. Even the failure is slight and only affects a few slope surfaces, if the failure region is not covered with soil restoration, the soil will be exposed to the sun and rain. Even though the failure is minimal and impacts a few slopes, as a tip, most slopes we see employ blue plastic to cover slippery or corrosive surfaces to prevent rainwater and air from entering the soil. Covering the slippery or corrosive surface. That concludes our findings for this project. That is all from us. Thank you.